Hello everyone, my name is Danish Kapoor with PMT, and today we are looking to export one of our projects in Edge to NC Simul. So I have this project on a Mazak Integrex i200. This is how it is set up on the main spindle. To give you a quick overview of the project, let's have a look at all the tools first up. So this is let me zoom in so we can have a look at this better. This is my 35-degree OD turn tool. The next I have is a 55-degree OD turn tool. Then ball mill 10 mm, and this is the 9.5 mm for finishing. I have also added a custom tool for this project for the sole purpose to see if we are able to export any of the custom tooling such as custom mill or custom insert easily from Edge to NCCML. So this is created with the ECT files, both the shank and the insert. And then this is the drilling tool that I have and another 80-degree OD turn tool that I have. And overview of the operations. So I just put in a few turning and milling toolpaths. So starting with the facing. So this is doing the facing, and then the OD roughing, which is done with the special tool, the custom tool, in fact, and the contour finishing, then the drilling. Next is what we are doing is the contouring, right? We're doing the roughing for these slots, right? Leaving a little bit of material and then we are finishing it off. All right, so the idea is to transfer all of this data into NC Simul, and we'll see how easy it is to transfer this data from Edge to NC Simul. Now, to transfer this data, there is this interface available. So let me go ahead and pop that open. So this is the interface I have. Now, as soon as you open that, you will get to select your machine. Now, on this work environment, I have two machines, similar configuration, Mazak Integrex and the Multus B400. I'm going to use the Integrex for this example. Now, it is smart enough to kind of identify what models do we have set up, because both softwares are developed by the same platform, Hexagon, so they have great communication between both. So if I click on models, based on the part and the stock defined under workpiece, so it is selecting the workpiece both for the part and stock, and for the fixture, the chuck is selected automatically, and based on the type of chuck or the fixture we have, it selects whether it's retractable, fixed, or machinable fixture we have. Now on all the other chucks we don't have anything, so nothing is selected for that, right? As far as the coordinates go, so this is going to be our fixture attachment point where the chuck meets the spindle. And then we can also select our datum. For this example, we are using G54, and then looking at our tooling library. So by default, it picks up the tools that we are using in our project. So these are all the tools that we are using. And if I want, I can export as many number of tools as I want. So let me just select the remaining tool as well. Initialization, we can define where kind of make a reference for our G54 or G55 we are using in our NC program. And then it is internally linked to the post in Edge. So we don't have to add the NC program manually as well. So all of these options are set up. So what we need to do is click on this button, send to NC Simul. And let's pop NC Simul open as well. All right, so here is all the data that we have imported from Edge. And please note that this is a demo machine, not a production ready model that I have, so it may have a few errors, all right, during the simulation. All right, so as we talked about, we wanted to export the part fixture stock along with the tooling. So the interface did that everything for us. This is the project tree. The machine is selected by default. On the setup, we were able to kind of export or import in NC Simul for that matter. Our part geometry, the stock, and our fixture. Here's the position of our datum. Let me hide the toolpaths. All right, and that's the position where my G54 is located. Everything seems to be set up correctly. Let's have a look into the tool library. Let's go ahead and edit that and see how the tools show up when we transfer it using the interface. Just taking a few seconds there. Oh, there we go. So that's our first tool. And the second tool that we have. All right, so beautiful looking tool. And let's look at the custom tool that we had there. So yeah, it seems to be coming in correctly. And then our drill and the ball mills. So all the tools that are defined in Edge are coming over in the same fashion. So we don't need to, make a library ahead of time or, having to import the CAD models separately. And then this is kind of the NC program that we posted, right? So it automatically kind of breaks it down into different tool sequences so we can start our simulation from that point. And also for the fact that if a change is made to the same NC program, you don't have to run the simulation again. So it saves the rest stock material up to the point of change. And once it finds that there is a change, it will ask you to rerun the simulation from that point on. All right, so enough of the talking. So let me switch to simulation. All right, let's see what's happening, and we can slow down the speed of simulation to see what's exactly happening, how our toolpaths are showing up. All right, let's click on the play button. So doing the facing initially, and we can switch to part and machine view side by side for better visibility, or if you want to analyze something. Doing the drilling here, let me zoom in. And those are the slots being roughed, and the next, those are going to be finished. And there we go. So it has successfully completed the simulation. The next we can do is do the dimensional analysis to make sure if we are hitting the required tolerances or not. So for that, we have this comparison mode. And once I click on that, it will show us the material that is remaining, that has been overcut, and we can define the range basically that so we can define the minimum and the maximum here and the step for color coding. All right, so that's pretty much everything I need to cover in this video. Thank you.